So the order of presentation here for the first question, again, is intelligent design scientific, and some of these issues is Loren Haarsma. And may I introduce Loren.
Thank you. Some of you have from time to time asked, is there a Sunday school resource on origins topics? And there's a new one out now aimed at high school, so get your pen out if you want to write this down, aimed at high school age but also adaptable to adults. So it's called Fossils and Faith. So write down Fossils and Faith, and CRC Publications is a publisher, and it starts by laying out Genesis 1 and hermeneutical issues. It then talks about the science. It lays out the range of responses within Christianity from young earth creationism to evolutionary creationism, and then it talks about earth keeping and stewardship at the end. So, enough of that. Okay, I need that back eventually. Yeah. All right. The majority of modern arguments for intelligent design fall into two categories. The first is that biological complexity cannot be explained via natural evolutionary mechanisms alone, and is best explained in terms of actions of an intelligent agent. And sometimes attempts are made to formalize this claim via probability arguments. The second common argument for ID is that the fundamental laws of nature appear to be fine-tuned for life. And this argument is typically left as an intuitive appeal without formal probability calculations. Now, I've been asked today to address the question of whether or not arguments like this should be considered scientific. And the answer obviously is both yes and no. But seriously now, I have found that the least productive arguments over ID have been the arguments over whether or not intelligent design is scientific. These arguments have been so unproductive, I believe, because intelligent design as a whole package is partly scientific, partly philosophical, and yes, partly religious. So I think the real question we should be asking is, are the scientific parts of ID good science? Are the philosophical parts of ID good philosophy? And are the religious arguments of ID good theology? So let's start with the science. I think it's useful to start with a broad picture of science that includes at least all of the questions that I list under point B on that handout that should be coming your way. Now, questions B2 and B3, which ask, what is an effective scientific method for learning about nature, and what do we learn about nature when we apply those methods? These questions are typically answered by scientists with little or no input from religion or philosophy or other academic disciplines. And that's probably the way it should be. But the other questions on the list about the basis for science, the societal impact of science, and the motives and ethics and goals for doing science, those questions are properly asked by scientists in conjunction with other disciplines, including philosophy and religion. Now imagine telling an historian that the discipline of history should restrict itself to just finding out bare facts about the past, what happened where and when. But all questions about the psychological, social, philosophical, and religious implications of those past events, well, that's beyond outside of history, and professional historical scholarship should ignore those questions. Now, if you said that to a historian, I expect that the historian would laugh you to derision. History overlaps with other disciplines, and it's appropriate for historians to speak on those areas of overlap. In the same way, scientists who feel motivated and competent to do so should not be shy about addressing questions where science overlaps with sociology, philosophy, and religion. However, although that broad definition of science can be useful, it's also useful to know that there is a narrower definition of science, very common today, which restricts itself to questions B2 and B3, and which acknowledges a critical role in science for constructing and testing explanatory models which only refer to natural causes. If we look at the history of science, we see that science really began to make progress when we stopped thinking about natural events in terms of nature spirits or in terms of Aristotelian final causes, and started trying to explain events in nature in terms of immediate natural causes. That's been critical for the development of science. Now, it might sound like I'm trying to exclude ID with this definition, but please note I'm not saying that science must ever and always restrict itself to naturalistic explanations. I'm only saying that models which restrict themselves to natural causes play a critical role in science. And advocates of ID ought to agree with that because they themselves routinely construct models which restrict themselves to known natural mechanisms as a step towards trying to show that those models are inadequate. So, what happens when scientists confront a puzzling event in nature and try to explain it using models which only rely on known natural mechanisms? Well, these models are tested and they meet varying levels of success, which I list under point D on your handout. Many things in science are now in category D1, explainable in terms of known natural laws. For example, the regular motion, orbital motion of planets, or the fuel source of the sun. Perhaps the majority of things in science fall into category D2. How did the first galaxies form? How can a tree grow from a single seed into a mature plant? How do birds learn when and where to migrate? We know some of the mechanisms of those processes, but we know that we don't know other mechanisms. We expect that future research will turn up some interesting facts and concepts and surprises. However, although we can only partially explain those things right now, it looks to us like natural mechanisms will do the job. We don't expect that future research into these questions will turn up anything that just can't be explained by known natural processes. Scientists spend most of their time trying to push things from the partially explainable category into the fully explainable category, and this is how we make progress in science most of the time. But there are those rare occasions in science where an event seems to fall into category D3, unexplainable. Not only are we unable to construct a model for the event in terms of known natural laws, but we can even come up with good quantitative arguments why any model which relies only on known natural mechanisms would seem to be excluded. Now, those are rare events, but here's one historical example. A period in the late 1800s when the energy source of the sun was a mystery. At that time, there was good evidence that the Earth, and therefore the sun, was at least hundreds of millions of years old, but the known energy mechanisms of chemical burning and gravitational collapse could be shown to be inadequate to fuel the sun for that long a period. The energy source of the sun was unexplainable in terms of known natural mechanisms at the time. And the solution to this puzzle was the discovery of an entirely new natural mechanism, nuclear fusion. Today, the source of the Big Bang falls in category D3, unexplainable in terms of known natural laws. Now, scientists can and do hypothesize new natural laws acting in some primordial vacuum or some mother universe which might cause the Big Bang, and that's an ongoing area of research. However, there are no currently known natural laws for which we have independent evidence which could explain the source of the Big Bang. So, what do scientists do when they confront something that's unexplainable? Well, individual scientists could reach a variety of conclusions about the cause of the event, and I list 5 under point E in your handout.